Okay, all right. So what this does, we're looking at what these mean. The arc sign means the inverse sine. But that's only true if and only if that the sine of y is x. Okay, your y values can only be between negative pi over 2 and pi over 2. And your x values that you get out of that are between negative 1 and 1. I want to remember, arc sine is only defined for this half moon of the unit circle, is what I always say. Okay? So the left half moon. Our cosine is only defined for the top half moon. That's why it's from 0 to pi. And our tangent is only defined for the right half moon, which is from negative pi over 2 to pi over 2. Okay? All right. Now, the second part of this is, by the way, since these are inverses of each other, the sine of the arc sine is equal to x, but only provided that the x values are between negative 1 and 1. It is not valid if the values are outside of it. It's not defined. Okay? All right. One thing we need to understand is, what does this mean? So we're going to draw a picture of this. So given that the y is equal to the arc sine, find the cosine of y and the tangent of y. And whenever you're given one involves an arc sine and one of these, draw the picture. And what this means is the angle y is equal to the ratio of x over 1, where this is the opposite side and this is the hypotenuse. Okay? If you do Pythagorean theorem on this, we need to find this third side. So that third side works out to be, if you do the box squared plus x squared is 1, the box squared is equal to 1 minus x squared, or the box is just equal to the square root of 1 minus x squared. Okay? Since we're only on this one, we don't have to do the plus or minus here. Okay? Since we're only on this region here. So now I know that this side is equal to the square root of 1 minus x squared. So that's what this means. Now we're just going to go find the cosine of that. Well, that's pretty simple. The cosine of y from my picture is now equal to the adjacent over the hypotenuse, which is just root 1 minus x squared. Okay? The tangent of that picture, of which is y, is just equal to the opposite side over the adjacent, which is x over the square root of 1 minus x squared. Again, this is only defined for certain values. By the way, in fact, this is only defined as long as x is less than or equal to 1. This is only defined when x is less than 1. Why? If it's bigger than 1, or if it can't be, but this has to be less than 1, so as we get a imaginary number, this cannot be equal to 1, because if it's equal to 1, then I'm undefined. Okay? All right. So what does this mean? We're just going to find what the y equals. So all we're going to do is draw this picture and then take the tangent of it. So, but I don't know the arc secant. That's the problem. But I know the arc cosine. And that means whenever it's for here, that means I have to flip the argument. Okay? That means exactly the same thing. Okay? So I have to flip the argument in this case. Okay? All right. So I'm now going to draw that picture, which means now the adjacent, well, you could do it from here. This is the adjacent over the hypotenuse, or it's the hypotenuse of the adjacent, so now it's the adjacent of the hypotenuse. So the adjacent side for this one is 2. The hypotenuse is root 5. Okay, if I do Pythagorean on it, this has to be 1. Because 2 squared plus 1 squared is 5. Root of that is 5. Okay, so now that's what this picture represents. So now I need to go take the tangent of that picture. Okay, and what is the tangent of that picture? So is 1/2. So y simply equals 1/2. Okay? All right. Last one on this page is we want to find that if the arc cosine is this, what's the cotangent of it? So we're going to draw that picture. Okay. But remember, arc cosine is only between 0 and pi. So we're only looking to draw it in here. And where is the cosine negative? It's over here. Okay, so this is the adjacent side, is negative root 3 over 2. By the way, the hypotenuse is always positive. So we have to make the x value negative. Okay? All right. Oops, a little bit off the screen. So this is the adjacent of the hypotenuse. Remember, the hypotenuse is always positive, so I have to make this piece negative. So when I square this, I get 3 plus what is 4 is it's 1. Or if you do Pythagorean on it, it works. Okay, so what is the cotangent? Well, I don't know the cotangent, but I know the tangent of that angle is 1 over negative root 3. So the cotangent is going to be negative root 3 over 1. Because it's rise over run, so the cotangent is going to be run over rise. Okay? All right, just a little review about what this means. Okay, so that's all we did. Eventually we'll do some differentiation on this stuff, but you don't want to do it on this, you want to change it to that one. Okay, so the next one, we're going to do some derivatives. By the way, derivation is the thing I'm saving for next time. So these are the derivatives, the inverses, inverse trig functions. You do need to know them. Okay, is there a pattern on the left to the right? So here's the arc sine. It's u prime over the square root of 1 minus u squared. We do need to know that. And that's differentiated implicitly. Okay, but if you know the arc sine is this, the arc cosine is exactly the same, except it's what? Negative. Okay, the arc tangent is u prime over 1 plus u squared. So the arc cotangent is negative u prime over 1 plus u squared. Okay, arc secant is this goofy one, which is u prime over the absolute value of u times square root of u squared minus 1. And the other is the opposite. So, as I said, I'm going to save a derivation here. All we're going to do out here now is plug and chug. Okay, so I am looking for the arc tangent of e to the 3x, which if you think about how we did it up here, u is equal to e to the 3x, correct? So if you look at the arc tan, derivative of that, it's going to be u prime on top. Well, it's 1 plus u squared on the bottom, so it's 1 plus e to the 3x squared on the bottom. And then I have to put the derivative of this up top, although we have not done it yet. Wow, I forgot, so this is a little bit out of order. That's okay, but u prime, actually we're going to change this